Imagine a time when doctors believed that diseases were caused by bad air or imbalances in the body's fluids. This was the world before the germ theory of disease. The story of how this revolutionary idea took hold is one of curiosity, skepticism, and ultimately scientific triumph. In this video, we'll explore how the germ theory transformed medicine, changed public health, and saved countless lives. Let's begin our journey by understanding what people believed before microbes were discovered. For centuries, people explained illness through mystical or environmental causes. The miasma theory, for example, suggested that diseases like cholera and plague were spread by foul-smelling air. Others believed in humoral theory, which claimed that health depended on the balance of bodily fluids. These ideas shaped medical practice for generations, influencing how doctors treated patients and how societies responded to outbreaks. But as cities grew and epidemics spread, these explanations began to fall short. The 17th and 18th centuries, the scientific revolution was underway. New tools like the microscope allowed scientists to peer into a hidden world. Early pioneers such as Antony van Leeuwenhoek observed tiny animalcules in water, but their connection to disease was not yet understood. Curiosity grew as more scientists began to question old beliefs and search for concrete evidence. This spirit of inquiry set the stage for a dramatic shift in how we understand illness. Invention of the microscope was a turning point. Suddenly, scientists could see microorganisms, bacteria, protozoa, and more that were invisible to the naked eye. Antony van Leeuwenhoek's detailed drawings and descriptions fascinated the scientific community. However, the link between these tiny creatures and disease was still missing. The world was on the brink of a major discovery, but it would take decades for the pieces to come together. As more evidence accumulated, some scientists began to doubt the miasma theory. Outbreaks didn't always follow patterns of bad air, and some diseases seemed to spread in ways that couldn't be explained by environmental factors alone. The search for a better explanation intensified, leading to heated debates within the medical community. The stage was set for a new theory to emerge, one that would forever change our understanding of disease. The mid-1800s, Hungarian physician Ignaz Semmelweis made a startling observation. He noticed that women in maternity wards attended by doctors had much higher rates of childbed fever than those attended by midwives. Semmelweis hypothesized that doctors were carrying infectious material from autopsies to patients. By introducing handwashing with chlorinated lime, he dramatically reduced deaths. Though his ideas faced resistance, Semmelweis's work hinted at the power of invisible agents. Another breakthrough came from English physician John Snow during a cholera outbreak in London. Snow mapped cases and traced the source to a contaminated water pump on Broad Street. By removing the pump handle, he stopped the outbreak. Snow's work showed that diseases could be spread by specific sources, not just bad air. His findings were a crucial step toward understanding the role of microbes in disease transmission. French chemist Louis Pasteur played a pivotal role in establishing the germ theory. Through experiments with fermentation and spoilage, Pasteur demonstrated that microorganisms were responsible for these processes. He showed that sterilized broth remained free of microbes unless exposed to contaminated air. Pasteur's work not only debunked spontaneous generation, but also provided strong evidence that germs could cause disease. Pasteur's discoveries led to practical applications such as pasteurization, a process of heating liquids to kill harmful microbes. This innovation made milk and other foods safer, reducing the spread of diseases like tuberculosis. Pasteurization became a cornerstone of public health, demonstrating how understanding germs could lead to life-saving interventions. The world was beginning to see the power of the germ theory in action. German physician Robert Koch took the germ theory further by identifying specific microbes that cause specific diseases. Using innovative staining techniques in pure cultures, Koch isolated the bacteria responsible for anthrax, tuberculosis, and cholera. His meticulous methods set new standards for scientific research and provided undeniable proof that germs were the culprits behind many deadly illnesses. To establish a clear link between microbes and disease, Koch developed a set of criteria known as Koch's Postulates. These guidelines required that a microorganism be found in all cases of a disease, isolated and grown in pure culture, and cause the same disease when introduced to a healthy host. Koch's postulate became a gold standard for proving causation in infectious diseases, shaping the future of microbiology. Despite mounting evidence, the germ theory faced resistance from some doctors and scientists. Many were reluctant to abandon long-held beliefs and practices. However, as more experiments confirmed the role of microbes, acceptance grew. Medical schools began teaching the new theory and hospitals adopted stricter hygiene protocols. The shift was slow but unstoppable, marking a new era in medicine. With the acceptance of germ theory, hygiene became a top priority in medical settings. Doctors and nurses started washing hands, sterilizing instruments, and wearing clean clothing. These changes dramatically reduced infections in hospitals and saved countless lives. The importance of cleanliness became a central tenet of modern medicine, all thanks to the understanding of germs. Germ theory also paved the way for vaccines. By understanding which microbes cause diseases, scientists could develop targeted vaccines to prevent them. Louis Pasteur created vaccines for rabies and anthrax, while others followed with vaccines for smallpox, polio, and more. Vaccination campaigns became a powerful tool in the fight against infectious diseases, saving millions of lives worldwide. For germ theory, surgery was incredibly risky due to infections. British surgeon Joseph Lister applied Pasteur's ideas and introduced antiseptics, chemicals that kill germs, to surgical practice. By sterilizing instruments and cleaning wounds, Lister drastically reduced post-surgical infections. His work revolutionized surgery and made complex operations much safer for patients. Armed with new knowledge, governments and health organizations launched public health campaigns to control infectious diseases. Efforts included promoting handwashing, improving sanitation, and providing clean water. These initiatives helped curb outbreaks and improved overall health. The germ theory's impact extended far beyond hospitals, shaping how entire communities protected themselves from disease. As scientists continued to explore the microbial world, they discovered agents even smaller than bacteria, viruses. These tiny particles could pass through filters that trap bacteria and cause diseases like rabies and influenza. The discovery of viruses expanded the germ theory and opened new frontiers in medicine, leading to the development of antiviral drugs and vaccines. Discovery of antibiotics in the 20th century was another milestone. Alexander Fleming's identification of penicillin ushered in a new era of medicine, allowing doctors to treat bacterial infections effectively. Antibiotics saved millions of lives and made once deadly diseases manageable. The germ theory provided the foundation for these breakthroughs, highlighting the importance of targeting specific microbes. Modern laboratories became essential for diagnosing and studying infectious diseases. Scientists used advanced techniques to identify pathogens, track outbreaks, and develop new treatments. The germ theory transformed labs into the front lines of disease control, where researchers continue to battle emerging threats and protect public health. Principles of germ theory influence our daily routines, from washing hands to cooking food thoroughly. Public awareness campaigns teach people how to prevent infections at home, school, and work. Simple habits like covering coughs and cleaning surfaces help stop the spread of germs, showing how scientific discoveries can shape everyday behavior. Adoption of germ theory has had a profound impact on global health. Life expectancy has increased, infant mortality has dropped, and many infectious diseases have been brought under control. International cooperation in disease surveillance and vaccination campaigns continues to save lives, demonstrating the lasting legacy of this scientific revolution. Despite its successes, the germ theory has faced challenges. Some diseases like cancer and autoimmune disorders are not caused by microbes. Antibiotic resistance has emerged as a major threat, making some infections harder to treat. Scientists continue to refine our understanding of disease, integrating new discoveries with the foundational principles of germ theory. Today, microbiology is a vibrant field, exploring everything from beneficial gut bacteria to deadly pathogens. Advances in genetic sequencing and molecular biology allow scientists to study microbes in unprecedented detail. These discoveries are leading to new treatments, diagnostics, and a deeper understanding of the complex relationship between humans and microbes. One of the most exciting discoveries is the human microbiome, the vast community of microbes living in and on our bodies. These microorganisms play crucial roles in digestion, immunity, and even mental health. Understanding the microbiome is reshaping medicine, highlighting the importance of balance and diversity in our microbial partners. COVID-19 pandemic underscored the relevance of germ theory in the modern world. Understanding how viruses spread informed public health measures like mask wearing, hand hygiene, and vaccination. Scientists raced to develop tests, treatments, and vaccines, relying on principles established over a century ago. The fight against COVID-19 is a testament to the enduring power of the germ theory. Teaching the principles of germ theory is essential for public health. Schools, media, and health organizations work together to educate people about infection prevention. Knowledge empowers individuals to make informed choices, protecting themselves and their communities from disease. Education remains a key weapon in the ongoing battle against infectious threats. In many developing countries, the principles of germ theory are still being implemented. Efforts to improve sanitation, provide clean water, and promote vaccination are ongoing. These initiatives face challenges, but progress continues as communities embrace the science behind disease prevention. The global fight against infectious diseases is far from over. Looking ahead, the fight against infectious diseases will rely on both old and new strategies. Advances in technology, rapid diagnostics, and global cooperation will be crucial. The lessons of germ theory continue to guide researchers and policymakers as they prepare for future challenges, from emerging pathogens to antibiotic resistance. Each of us plays a role in preventing the spread of disease. Simple actions like washing hands, staying home when sick, and getting vaccinated make a difference. The germ theory reminds us that our choices can protect not only ourselves but also those around us. Personal responsibility is a cornerstone of public health. Scientists continue to search for cures and treatments for infectious diseases. From new antibiotics to innovative vaccines, research is ongoing. The germ theory provides a roadmap for these efforts, guiding scientists as they unravel the mysteries of the microbial world and develop life-saving interventions. Recent research suggests that microbes may play a role in some chronic diseases such as ulcers and certain cancers. The discovery of Helicobacter pylori as a cause of stomach ulcers challenged previous assumptions. Scientists are now exploring the links between microbes and conditions like diabetes, obesity, and even mental health, expanding the reach of germ theory. Technology has revolutionized the study of microbes. Tools like electron microscopes, DNA sequencing, and computer modeling allow scientists to investigate pathogens in incredible detail. These advances have accelerated discoveries and improved our ability to diagnose, treat, and prevent infectious diseases. The fight against infectious diseases is a global effort. Scientists, doctors, and public health officials collaborate across borders to share data, track outbreaks, and develop solutions. The germ theory has fostered a spirit of cooperation, reminding us that health is a shared responsibility. Disease surveillance is critical for early detection and response to outbreaks. Public health agencies monitor trends, investigate cases, and coordinate interventions. The germ theory underpins these efforts, providing the scientific basis for tracking and controlling infectious threats. The concept of germs has entered popular culture, shaping how we think about cleanliness and health. From advertisements for disinfectants to movies about pandemics, the influence of germ theory is everywhere. This widespread awareness helps reinforce healthy habits and supports public health goals. Controlling infectious diseases raises important ethical questions. Balancing individual rights with community safety can be challenging. Quarantines, vaccination mandates, and travel restrictions are sometimes necessary, but they must be implemented fairly and transparently. The germ theory provides the rationale for these measures, but ethical considerations remain central. History of germ theory teaches us the value of scientific inquiry, open-mindedness, and perseverance. Progress was not always smooth, and many pioneers faced skepticism and opposition. Yet their dedication laid the groundwork for modern medicine and public health, reminding us that science is a journey of discovery. Prevention is one of the greatest gifts of the germ theory. By understanding how diseases spread, we can take steps to stop them before they start. Vaccines, sanitation, and education are powerful tools that protect individuals and communities, reducing suffering and saving lives. The microbial world is constantly changing, with new pathogens emerging and old ones evolving. Scientists and public health officials must stay vigilant, adapting strategies to meet new challenges. The principles of germ theory provide a solid foundation, but flexibility and innovation are essential for success. Environmental factors play a role in the spread of infectious diseases. Clean water, proper waste disposal, and healthy ecosystems help prevent outbreaks. The germ theory highlights the interconnectedness of human health and the environment, encouraging sustainable practices that benefit everyone. Effective policies are essential for controlling infectious diseases. Governments must invest in healthcare, support research, and enforce regulations that protect public health. The germ theory provides the scientific justification for these actions, guiding policymakers as they make decisions that affect millions. The story of germ theory is a celebration of human curiosity and ingenuity. From early observations to modern breakthroughs, each discovery has brought us closer to a healthier world. By honoring the achievements of scientists past and present, we inspire future generations to continue the quest for knowledge. The legacy of germ theory lives on in every hospital, laboratory, and home. Its principles guide our actions, inform our policies, and shape our understanding of health. As we face new challenges, the lessons of germ theory remind us that science, collaboration, and vigilance are our best defenses. As we look to the future, the fight against infectious diseases continues. New technologies, global cooperation, and a commitment to science will be essential. The germ theory has shown us what's possible when we seek understanding and work together. The journey is ongoing, and the next chapter is waiting to be written. Summary: the germ theory of disease revolutionized medicine and public health. It replaced outdated ideas with evidence-based science, leading to life-saving innovations and healthier societies. The journey from skepticism to acceptance was long, but its impact is undeniable. As we reflect on this remarkable story, we're reminded of the power of discovery and the importance of staying curious, vigilant, and united in the face of new challenges.